Birds are in their own species. They lay eggs like a reptile, but they have other qualities to them that are unique, most obviously their wings. Although not all birds can fly, they all have wings. Another less obvious trait that birds have is hollow bones. This enables them to fly. Finally, there are feathers, which are the distinguishing mark of birds. They are used to make flight easier. But there once was a time before all these traits helped them fly and eat. The dinosaur ancestors used these traits to perform other tasks. Early birds from a million years ago had toothed jaws and clawed fingers and were about the size of a sparrow. Before they developed into birds, the hollow bones and claw shapes served other purposes, specifically allowing for these small animals to run very fast away from predators. Later on, evolution helped the aviation aspect of a bird. The hollow bones made them light enough for flight, and their claw shapes enabled them to perch on branches. The fact that birds are bipedal and lay eggs is diverted from their dinosaur ancestors. Dinosaurs developed from pteropods, four-legged animals, to bipedal because the ability to walk on only two legs gave them much more mobility and allowed for these predators to chase down other animals. This skeletal structure eventually developed into the relative shape of a bird.
Natural selection was a big part in the evolution of birds. Over time, the first birds migrated away from each other and developed in different environments. These environments had different foods and predators. Thus, natural selection caused the birds to branch off into different species. A perfect example of how natural selection changes the birds is in the Galapagos Islands.
Every generation of finches, there's a range of beak sizes, some a little smaller than the average, some a little larger. When small seeds are plentiful, when there's been plenty of rain, the smaller beaked birds are the more efficient eaters, so they thrive and produce more offspring than the larger beaked birds. The result is that in the next generation, there are more small than large beaked birds. The average beak size is smaller than the last generation. The population has evolved.
This phenomena is a modern example of how natural selection acts in the world. Big evidence has been found to link birds to their dinosaur ancestors. The Origin of Birds by Gerard Heilman was a book that first proposed the idea that birds had developed from theropod ancestry due to their similar bone structures. A few years later, a known ornithologist, John Ostrom, proposed the idea that birds in fact were direct descendants of dinosaurs. Using the fossils of Deinonychus and Archaeopteryx, he established that the bone structures of 3 toes, 3-fingered hands, and half-moon-shaped wrist bones were all developments of dinosaurs that were common in birds too. The Archaeopteryx is the oldest known bird discovered. Its uncanny resemblance to raptors and smaller carnivores of the time led Ostrom to make the conclusions that birds in fact came from dinosaurs. Although birds all stemmed from a common ancestor, how did they develop to be so different? The answer to that question is geographic isolation. As birds developed into a species, natural events occurred that caused the birds to move into different climates and environments. These environments made certain traits more desirable and other traits less desirable. So when a mutation popped up that helped survival, it was passed down from generation to generation until it became a norm. Again, Darwin's finches are a great example to use. As the birds developed to suit their survival needs on their specific islands, they became more and more different. So once they met up again, they were no longer interested in mating. Them not mating is a result of reproductive isolation. This is when something involved in the mating process is changed and makes two species no longer compatible. Birds on the Galapagos Island don't interbreed due to the fact that the other species don't have mating calls that are attractive to them. The fact that they don't interbreed is what defines them as a species.
Evolution does not directly affect people because it takes many generations for even a minor evolutionary change to occur. The most obvious exception is the evolution of viruses and bacteria. This is due to the extremely short lifespan of these microorganisms. Many generations occur in less than 1 year. Microorganisms can sometimes evolve or mutate into something different to last year. For example, we may have built up immunity to last year's influenza strain, but we find we have no immunity to this year's strain. Similarly, the avian flu, also known as the bird flu, was able to evolve in such a way that it could survive even proliferate in humans, jumping species from birds to humans. The most obvious current example of evolution is in the strains of bacteria that are resistant to antibiotics, like MRSA. Excessive use of antibiotics or incorrect use of antibiotics, such as not finishing the course of treatment, has led to the emergence of several strains of pathogenic bacteria that can no longer be effectively treated with antibiotics, making their treatment much more problematic.